Here we see the representation of a single photon of light. Scientists understand many of the properties of light, but light still holds some mysteries that perplex us. Thomas Young first demonstrated the wave nature of light in 1803 with his famed double-slit experiment, and ever since then the world's top minds have debated what the results of this experiment actually mean. Although Young's double-slit experiment is repeated many times every day, we are always left with the same perplexing question that goes to the core of quantum mechanics and even our very understanding of matter. Is light a particle or a wave? Experiments have revealed that light has the properties of both a particle and a wave, but how can it be both a particle and a wave? Then we find this to be the case for all electromagnetic radiation and all matter. This leaves the world's brightest minds still searching for answers to this basic question: is matter a particle or a wave? In this video series you will be shown the solution to our dilemma. In fact, you are looking at that solution right now. The fields shown around the green photon are electromagnetic fields of opposite polarity, with the red field being of north magnetic orientation and the blue field being of south magnetic orientation. It will be proven that this is actually the way that magnetic fields are structured around all matter. This applies from the smallest particles we have discovered to the largest structures in space. If you were to measure these fields with a compass, their magnetic fields would appear identical to the magnetic fields of a bar magnet. This also means that when we measured the magnetic fields of matter with other methods in the lab, we also assumed that matter had a bar magnet type of magnetic field. But this assumption was a mistake. So until now we have incorrectly assumed that electrons and other matter have a magnetic field shape as shown in this drawing. But we must realize that the fields around an electron, as well as around all other matter, are actually two opposing bowl-shaped electromagnetic fields. Unless we properly understand this basic magnetic field structure, we will never be able to properly understand the fundamental forces of matter from the subatomic to the galactic. In this presentation, you will be shown that correcting this one basic misunderstanding of magnetic fields also explains most all of our problems in physics and astrophysics. I believe that this magnetic field structure is an intrinsic property of all matter. Therefore, you cannot have a particle of matter unless these magnetic fields are there to form it and confine it. To further understand these magnetic fields and validate this new theory, hundreds of experiments were conducted utilizing a vacuum chamber and specially constructed bowl-shaped magnetic field emitters. When 70,000 volts of electricity is applied, the plasma formations that you are now seeing appear. A variety of purging gases were used in these experiments. This includes ordinary air, argon, hydrogen, and helium. The spacing and orientation of the magnetic field emitters were varied in many ways as well. The magnetic field emitters were suspended on non-conductive, high-strength microfilament line attached to magnetic supports on the inner surface of the vacuum chamber. Then, to hold these supports in place, high-strength magnets were utilized on the outer surface of the vacuum chamber. This arrangement allows for the adjustment of the magnetic field emitters while the experiment is running. The small microfilament support lines also offer minimum disturbance of the plasma flow around the fields and therefore a more realistic experimental result. A variety of bowl-shaped magnetic field emitters were utilized in these experiments in order to reveal how changing the geometry of the field emitters affects the matter around them. As you can clearly see here, a change of magnetic field emitter geometry also results in a change in the shape of the plasma formation within the vacuum chamber. By adjusting the exposure settings on the camera, an X-shaped pattern is revealed between the magnetic field emitters that is amazingly similar to the shape of the red square nebula. You can even see the bowl shape of the magnetic fields in the red square nebula. Notice how increasing the spacing between the magnetic field emitters transforms the shape of the nucleus until finally a disk of plasma forms around the nucleus. Also notice the rapid spin of the plasma around the magnetic field emitters, even though the field emitters are stationary. Here you can clearly see how even a single magnetic field emitter controls the shape of the plasma around it. Notice how it confines the plasma to the lower part of the vacuum chamber. In preparing for this research, I pondered what other geometries of bowl-shaped magnetic field emitters would be beneficial for this research. I carefully studied the structures in space for guidance in the design of a new bowl-shaped field emitter. From the structures in space to the structures of matter revealed in the collisions at the Large Hadron Collider at CERN, all sources of data were considered. I carefully studied the amazing research underway at the Large Hadron Collider, and I found a wealth of evidence for this new theory in the collisions there. This evidence will be discussed at length in Primer Fields Part 4. In reviewing a video from CERN, I noticed something quite bizarre, and it wasn't in the data from the collisions. It was in the shape of CERN's most well-recognized building, the Globe of Science and Innovation in Geneva, Switzerland. Not only was it a bowl shape, but the design of the building also had a hole in the top of the dome, exactly as my theory would call for. So I made a magnetic scale model of the CERN dome, placed a set of them in my vacuum chamber, and fired it up. Not only did these CERN bowls form a spherical shape at the center of the reaction, but they also formed a disk of plasma around the nucleus, as well as ejection jets along the axis. After running the experiments for a few days with the CERN bowls, they were removed from the vacuum chamber and photographed, revealing the patterns you see here. These amazing patterns will also be discussed further in Part 4 of this series of videos. Then once it was realized that the key pattern required for this theory was found in the dome at CERN, it was also discovered that CERN was not the only place with the required pattern. The pattern has been there for centuries at the Pantheon in Rome, which has been referred to as the vault of the heavens. Then the required shape was also found at St. Peter's Basilica. Then one of my favorites was found at St. Paul's Cathedral in Medina, Malta. Notice the angels circling the hole at the top of the dome, and compare that to the glowing ring that is found inside the bowl-shaped magnetic field emitters in the vacuum chamber. Why are these angels on fire exactly where they should be? Much more on this dome and the others later in this series of videos. So it seems that people often want a sign from God that we are not alone. Sometimes God does give us a sign if we just pay attention. Sometimes he even puts that sign up over the capital of the United States of America. Then we will take a look at Newgrange in Ireland. This structure predates Stonehenge by over 200 years, and yet it too contains unbelievable details related to this new theory of the structure of all matter. More on Newgrange later in this video series. Here we have the assortment of the magnetic field emitters that were utilized in my research and in this video series. These emitters all have the same basic properties, but they do vary in size, geometry, and magnetic field strength. The design and construction of these field emitters are covered by patents that have been filed in both the United States of America and internationally. No rights to the use of the technology covered by these patents is granted or implied, as clearly stated in the statement at the beginning of this video. Notice how these ordinary non-magnetized steel balls are held in place at the center or nucleus of these field emitters. Then we will take a look at the data from the Sun. You will be shown how the results from the vacuum chamber experiments match the data and features of the Sun. This includes super rotation about the equator and the patterns of the surface flows on the Sun. We will also see the amazing confirmation of this new theory in the data from probes such as the Ulysses mission, which mapped many of the characteristics of the Sun. You will even be given an entirely new theory as to the true cause of the solar cycle and an explanation of the so-called coronal heating problem. This will all be covered in detail in part 5 of this video series. You will clearly see how this new theory explains the structure of not only the Sun, but also all matter, from electrons, to atoms, to molecules, to planets, to stars, to nebula, and even to entire galaxies. You will see amazing proof of these bowl-shaped magnetic fields at work on and around Saturn in part 2 of this video series. We will look at how relativistic jets are truly formed and experiments that were conducted in the lab to confirm this new jet formation theory. This will be covered in great detail in part 2 of this video series. Part 6 of this video series includes over an hour of video and images of the high-voltage plasma experiments that were conducted in the vacuum chamber. After completing hundreds of these vacuum chamber experiments, I am positive that the answers to both the energy crisis and global warming are now within our reach. Utilizing this new knowledge of the true forces that hold all matter together, a radically new type of energy reactor is in the works. These energy reactors will be very small, safe, and relatively inexpensive. So the dream of low-cost electricity is at the door. As you can see here, we are already well on our way to fulfilling our dream. Plus, there is an additional benefit to this technology: zero carbon emissions. We still have some work to do, but it really shouldn't take that long, now that we finally have the true understanding of the forces that bind all matter. Testing on this new reactor should begin by the summer of 2013. But there is other technology based on this new theory that has already been in the testing phase for over 6 years. Results so far have been amazing, and this product will be announced in the first quarter of 2013. But that's for later. For now, let's get back to how these fields work to confine matter. Here we see how the plasma spins and flows. In upcoming sections of this video series, we will examine this flow in more detail and its relationship to the spokes in the rings of Saturn and the solar wind. Then we will take a look at how these bowl-shaped magnetic field emitters cause both magnetized and non-magnetized balls to form the amazing arrays shown here. The only thing holding these balls in position are the magnetic fields emanating from these two bowls. Could this truly be the way that atomic and molecular structures are properly explained? I believe so. Let's take a look at the forces at work in the nucleus area of these bowl-shaped magnetic fields. Shown here are ordinary non-magnetized 5mm steel balls. These bowl-shaped magnetic fields induce a magnetic field into each steel ball, which causes them to repel each other while at the same time keeping the balls structured together. So this mysterious force not only causes the steel balls to become packed tightly together, but it also keeps them apart. Then it does this while at the same time forming a geometrically balanced pattern, just as we find within atoms and molecules. Notice the vibration in all of the steel balls as each new ball is added to the nucleus area. What we see at work here is what I believe would truly be defined as the strong force. Then we will take a look at some incredible cutting-edge research from scientists at IBM. This is an atomic force microscope image of the actual structure within a nanographene molecule. Now we see the image of the nanographene molecule superimposed on top of the array of steel balls that were formed in the nucleus area of the bowl-shaped magnetic fields. The steel balls are supported by a sheet of clear acrylic, which does not come in contact with the magnetic bowls at all. Therefore, it is only the magnetic fields of the red and blue bowls which are responsible for the shape of the patterns we observe here. Here we see 3mm steel balls in the nucleus area of the magnetic fields. Notice how they can trade positions with the other balls in the array, but the basic geometric pattern is always maintained. Now let's take a look at how these non-magnetized steel balls form orbital patterns around these bowl-shaped magnetic field emitters. Again, notice how even in the orbital area, these magnetic fields cause the steel balls to be packed tightly together, and yet at the same time they repel each other. Even 25mm non-magnetized steel balls follow these same rules. I believe it is time to reevaluate our theories of atomic structure and the forces at work therein. As you can see, a wide range of steel balls were placed around these magnetic fields with the same basic results. Here we see 5mm non-magnetized steel balls forming a complex array of orbitals around the nucleus. Notice how the steel balls all repel each other. The red and blue balls are identical in construction and magnetic strength. The only difference is the magnetic polarity of the balls. The red balls are north magnetic polarity and the blue balls are south magnetic polarity. Notice the various ways in which these balls will bond with each other. Here we see how the large and small balls interact with each other magnetically. Notice how the small blue ball is forced to flip over and then floats within the large red ball. The small red ball responds quite differently, as you can clearly see. Then we find the same rules in effect within the large blue ball. Now you see how the orbital distance of the small ball set is determined by the spacing between the large red and blue balls. This same principle applies to magnetic balls placed within the orbital equator area perpendicular to the large balls. In this demonstration, a singular magnetic ball is held in place by the magnetic balls, and then a second magnetic ball is added. Then it was discovered that this orbital effect is there even when the polarity of the magnetic field emitters is reversed. Pouring 2mm steel balls into the large bowls reveal the true forces at work in the Southern Crab Nebula. A wide variety of methods were used to study the magnetic fields emanating from these bowls. Here we see ferrofluid at work, showing the magnetic patterns formed within these bowl-shaped magnetic field emitters. Then for the very first time, it's now possible to actually repel non-magnetized steel balls with a static magnetic field. The magnetic field emitted from these bowls induces a magnetic field into the steel ball and then repels it along the axis of these magnetic field emitters. This knowledge is the key to understanding how these magnetic fields confine the nucleus of all matter, from electrons to galaxies. In this experiment, the anode, or the positive side of the high-voltage electrical supply, has been disconnected from the lower part of the vacuum chamber. As you can see here, the ejection jets are formed by the magnetic field emitters, even if one of the positively charged anodes is removed from within the vacuum chamber. So you should be starting to understand that a critical mistake was made by scientists when it was assumed that the magnetic fields emanating from matter such as atoms was due to a simple bar-shaped magnetic field within the atom. This assumption led to many ill-formed ideas as to the true forces at work from the subatomic level to the galactic level. Correct this one basic misunderstanding, and then many difficult problems in science become very clear and easy to understand. Here we see iron filings revealing the magnetic field lines around a bar magnet. Now we see a compass being used to reveal the magnetic field around the bowl-shaped emitter set. Notice that the field emitted from both the bowls and the bar magnet are the same. No wonder mankind was unaware of these bowl-shaped magnetic fields. They were hiding right in front of us the whole time. In this image, the magnetic field lines around the typical structure of an atom, a star, or even a galaxy are shown in magenta. But we need to remember that even though the magnetic field lines measured around matter are of this shape, it is not due to a bar-shaped magnet along the axis of the matter being measured. There are in reality dual bowl-shaped magnetic fields around the nucleus that cause this measured shape of magnetic field lines. So here is the basic shape of the magnetic fields that emanate from a typical structure in space. Now let's examine some structures in space and see if we can't find evidence for this shape at work in galactic formations. Here is how we were mistaken in our understanding of the true forces at work in galactic structures. These large structures in space could not be explained by the currently accepted theory of gravity alone. So as we studied these structures, it was assumed that some extra source of gravity was required to explain how all this matter could be held in orbit around the central star in these galaxies. This is how the theory of black holes became accepted when trying to explain these structures. It was a totally reasonable line of thinking. But it was found that even using black holes with incredible gravity, we could still not explain how these large structures in space are held together and function. So the next mistake that we made was to assume that some other extra matter was there to explain these large structures in space. Along came our theory of dark matter. But even when we applied both the theory of black holes and dark matter to our puzzle, there still were some problems. It seems the universe itself was not only expanding, but that rate of expansion was increasing. To explain this, we came up with the theory of dark energy. So now we have invented three totally unproven theories to explain what we find in the visible and known matter in space: black holes, dark matter, and dark energy. But they are not required at all if you eliminate the basic misunderstanding of magnetic fields around the nucleus of all structures in space. Once you properly understand this revolutionary theory of how magnetic fields can cause not only plasma, but actual matter to form the structures we find in space, you will clearly see that black holes, dark matter, and dark energy do not exist at all. We made some fatal mistakes in our thinking. Utilizing this new theory, you will find that even bizarre structures like Gomez's hamburger are now very easy to understand. As we explore this new theory, we will be examining images and data gathered by scientists, researchers, and astronauts. Their incredible efforts have made it possible for all of us to finally begin to truly understand the forces at work in our universe.
It's one small step for man, one giant leap for mankind.
We will be using images from telescopes in space, as well as images captured by a wide variety of telescopes here on Earth. Although I totally believe in plasma formations, there are clearly times where there is much more than just electricity and plasma required to explain what we see in space. This is the case in radio galaxy Hercules A. There is clearly actual matter being ejected along the axis of this galaxy from the evidence we see here. I have undertaken hundreds of plasma experiments, and I am convinced that external electricity alone cannot explain the formation we find in Hercules A. So let's take a look at how matter can be ejected by these bowl-shaped magnetic fields. So now I'm going to show you magnetic ejection utilizing the CERN ball. So this one will shoot these magnets, ordinary magnets, about 25 to 30 feet across the room if I have a large room. I don't have that big a room we're working in right now. So I'm just going to show you what it'll do. So pulls it down here, and I'll just put it in through the bottom, through the hole in the bottom. A little tricky, it doesn't really want to go in there. It's kind of against it. But then you get it to where it's a balance point, where it doesn't take any energy. But once you push it past that balance point, knowing that all matter has a magnetic component to it, you can now see how these incredibly strong bowl-shaped magnetic fields in space could accelerate matter to nearly the speed of light without requiring external electricity, black holes, dark matter, or even dark energy. Now let's take a look at some more formations in space and the magnetic fields around them. By now you can clearly see that the structures we find in space are easily explained by these bowl-shaped magnetic fields without using black holes, dark matter, or dark energy. It is important to note that these bowl-shaped magnetic fields will not always be nice, simple, symmetrical structures. They can be warped, twisted, offset, or one field might even be larger than the other as shown here. But once you understand the basics of this new theory of matter formation due to bowl-shaped magnetic fields, you will be able to easily explain most all of the structures we find in space. So to review, we have seen how these simple bowl-shaped fields operate in the vacuum chamber and the way in which they shape plasma. We have seen how glowing rings are formed within the bowl-shaped magnetic fields. We have also witnessed how the ejection jets are formed from these magnetic fields. We have seen how the shape of the reaction changes as we adjust the distance between the bowl-shaped magnetic field emitters. Then we have seen how a disk of plasma will form around the equator of the magnetic fields. We have also seen how these formations of plasma rotate at high speeds, even though the field emitters are stationary. We have seen how these bowl-shaped magnetic fields will cause both magnetized and non-magnetized balls to form orbital rings around the nucleus of the fields. Then in the nucleus area, we found that non-magnetized steel balls form geometrically shaped arrays that match the patterns found at the molecular level. We saw how non-magnetized steel balls formed amazing arrays around these bowl-shaped magnetic fields. It was seen how a magnetic ball was held in line with the equator of these bowl-shaped fields. We witness how the orbital distance is controlled by the spacing between these magnetic field emitters. We saw how pouring 2mm steel balls into one of these magnetic bowls revealed the true forces at work in the Southern Crab Nebula. It was shown how these bowl-shaped magnetic fields will repel non-magnetized steel balls away from the bottom of the bowl in line with the axis. We saw how these magnetic bowls will also eject matter at high velocities. Then finally, we saw how these bowl-shaped magnetic fields can explain most all of the structures we find in space without requiring black holes, dark matter, or dark energy. In part 2 of this video series, you will see more on how these bowl-shaped electromagnetic fields truly explain the structure of all matter, from the subatomic to the galactic. In the primer fields part 1, it was shown how two magnetic poles of opposite magnetic polarity would form a variety of plasma structures within a vacuum chamber. The color and shape of these plasma structures were clearly determined by the following factors: the shape of the magnetic poles, the spacing and orientation of the magnetic poles, the type of purging gas that was used, the vacuum level within the vacuum chamber, the electrical voltage used, the polarity of the direct current electricity used in the experiment, and the positioning of the electrodes within the vacuum chamber. All of these factors influence the shape of the plasma formations within the vacuum chamber. In the primer fields part 1, the plasma formations were often shown starting out with long arcs that gradually transitioned into a stable formation. This startup transition was due to a change in the vacuum level alone. Once the vacuum level is stabilized at the correct level for the plasma formation desired, the light emitted by the glowing plasma can be turned off and on instantly. So the electricity is not responsible for the fields that form the plasma formations. The electrical polarity determines how the plasma conforms to the fields, but the fields are not at all formed by the electricity. A reversal of the electrical current that causes the plasma to glow will cause an entirely different pattern to be revealed in the vacuum chamber, but this is due to a simple polarization change in the plasma which reveals a different aspect of the same field structure. The electrical polarity is not causing the fields to change, it is just changing how the plasma responds to the fields. Here we see the instantaneous effects of this electrical polarity reversal, as the DC electrical supply is switched between polarity states, just as you would flip a light switch on and off. In the primer fields part 1, it was shown how these opposing bowl-shaped magnetic field emitters control the formations of both steel and magnetic balls around the magnetic poles. It was also shown how 5 mm steel balls formed geometric patterns in the nucleus area between the two magnetic poles. We also saw that these steel balls repelled each other because of the magnetic field that was induced into each of them in the nucleus area. The magnetic bowls also induce magnetic fields into ordinary steel balls both inside the bowls and around the bowls. The induced magnetic fields then cause the steel balls to all repel each other, and at the same time the fields of the magnetic bowls confine the steel balls into organized rings and patterns. It is very clear that these magnetic bowl-shaped fields impart order into the matter around them, whether in the vacuum chamber or outside the vacuum chamber. It was also shown how one of these magnetic bowls would induce a magnetic field into an ordinary steel ball, which then caused the steel ball to be repelled away from the bottom of the bowl. Then by utilizing what we learned in the laboratory experiments, we were then able to come to understand the structures we find in space better than ever before. We discovered that we could now show how galaxies, stars, nebula, and most all other structures that we find in space could be explained without requiring black holes, dark matter, or dark energy. That brings us to part 2 in the Primer Field series. To begin with, we are going to explore the magnetic substructures that are found within these magnetic poles. The reason for the glowing rings that we see inside the magnetic poles in the vacuum chamber will be explained in this section of the Primer Fields. Understanding the function of these rings is critical to understanding how fusion works in the stars. It will also be shown how the bubbles inside the magnetic poles are caused by magnetic confinement, and how these magnetic bubbles are related to the ejection jets that are emitted from the top of these bubbles. This animation shows a magnetic bowl. In the bottom of the bowl we find 3 magnetic substructures. Now we will slice the bowl in order to get a better view of these magnetic substructures. I have named these magnetic substructures the confinement dome, the flip ring, and the choke ring. A regular compass is much too large to properly map the fields within the magnetic poles, so a much smaller magnetic compass was fabricated to map the fields in and around the magnetic poles. The red and blue arrows shown here indicate magnetic orientation and the direction of the flow of matter in and around the magnetic pole. The red arrows indicate magnetic north, and the blue arrows indicate magnetic south. Here we see a magnetic sphere being used to reveal the shape of the confinement dome. Here we see a string of magnets being used to show the magnetic field lines in and around the magnetic pole. Here we see an example of the ejection forces that exist within the magnetic poles. Then we see that this ejection force can be extremely strong. So just as we see in the plasma experiments in the vacuum chamber, we see that these ejection jets start at the top of the confinement dome and shoot out of the bowl in line with the axis of the bowl. Then when we take this knowledge and apply it to the Vela pulsar, we find some incredible validation of this theory. Notice how perfectly the bowl shape, flip ring, and ejection jets all match with the structure of the Vela pulsar. Once more, we see a magnetic sphere being used to reveal the shape of the confinement dome in the bottom of the magnetic bowl. The only way for the magnetic sphere to get under the confinement dome is for it to enter at the flip ring at the base of the confinement dome. Once under the confinement dome, the magnetic sphere is trapped under the confinement dome. If the magnetic sphere is forced above the confinement dome, we see that it is ejected up and then once again held above the confinement dome by the magnetic forces within the bowl. Now we have an animation showing how magnetic matter would react inside of the magnetic bowl. For now, we will be focusing on the function of the flip ring. The red and blue balls are labeled to indicate north and south magnetic polarity, red for magnetic north and blue for magnetic south. So as you can see, all the particles within the magnetic bowl are drawn to the flip ring, where they then enter the area under the confinement dome. Notice how at the flip ring the balls flip magnetic orientation. That is why I call it the flip ring, because it flips the magnetic orientation of the matter passing through it. This animation shows how particles of matter flow inside these magnetic bowls. The particles of matter entering the bowl are each induced with a magnetic field of their own. Then these particles of matter are drawn down to the flip ring, where they violently flip magnetic orientation and then become trapped under the confinement dome and above the choke ring. This flow of matter continues until the supply of available matter is exhausted. These bowl-shaped magnetic fields act as matter compressors. They will compress available matter until there is nothing left. That is why there is a vacuum in space. Most all of the available matter has been compressed so that all that remains in space is a vacuum. Now we will take a look at the function of the choke ring. Shown here are steel balls that are held in place at the choke ring. The balls are free to rotate around the choke ring, but they resist exiting out the bottom of the bowl or going back up into the bowl. The flow of matter is choked at the choke ring, which is why I call it the choke ring. The choke ring in the bottom of the blue bowl or the south magnetic pole, functions exactly the same, except the magnetic polarity of the choked matter is reversed. So here in the bottom of this bowl in the vacuum chamber, the glowing ring is the flip ring. In this view, we see how the flow of plasma is choked down as it goes through the hole in the bottom of the bowl. This is the choke ring at work, confining the plasma magnetically into a narrow stream. Now we are going to take a look at another magnetic substructure that exists below the bottom of the magnetic bowl. I refer to this area as the flip point. The flip point is in line with the axis of the bowl. Here we see the microcompass being used to show how the flip point flips the magnetic orientation of matter at the flip point. Past the flip point, matter is held away from the bottom of the bowl, but inside the flip point, matter is drawn into the bottom of the bowl. In this demonstration, notice that the steel ball is pulled towards the flip point and then held at the flip point by the interaction of the magnetic fields of the bowl and the induced magnetic field of the steel ball. This flip point repulsion is the reason we see the ejection of matter from the bottom of the Vela pulsar. In January of 2013, the Chandra X-ray Observatory released this series of images showing the flow of matter around and into the Vela pulsar. As you can clearly see, the matter is ejected out the top and out of the bottom of the Vela pulsar. Most of the matter coming out of the bottom of the Vela pulsar then moves up towards the top of the Vela pulsar's magnetic bowl, where it flows back down to the flip ring in the Vela pulsar. You can even see the evidence of the confinement dome above the flip ring in the bottom of the Vela pulsar's magnetic bowl. Despite what we have been told, the pulsation of the Vela pulsar is not due to a rapidly rotating neutron star. That is just what was theorized before the discovery of bowl-shaped magnetic fields. In a bowl-shaped magnetic field, the confinement dome is constantly trying to confine all the matter beneath it. But when the energy of this confined matter becomes too great, some of this confined energy escapes. Located at the top of the confinement dome is its weakest point, and this is where the confined energy escapes. In other words, this point in the confinement dome acts as a relief valve. If you Google relief valve chatter, you will see that relief valves can come to a point where they will release pressure in very rapid pulses. In other words, the relief valves will oscillate. Since the confinement dome is acting as a relief valve, it can come to a state where it is rapidly pulsing as it releases a burst of energy and then closes again, cutting the flow of energy being released. Since the confinement dome is operating as an electromagnetic relief valve, it can release these bursts of energy at very high frequencies. So pulses of energy can be rapidly released and then stopped immediately by this action of the confinement dome. This is why some pulsars exhibit these rapid pulses of energy that can suddenly stop and then restart hours or even days later. If we look at how these bowl-shaped magnetic fields function in the vacuum chamber, we see that they also emit energy in rapid pulses. In the ejection jet of HH-111, we can see very definite pulses in the matter ejected. By comparing the jet of HH-111 with a jet that is externally electrically driven in the vacuum chamber, we see that they have dramatically different structures. HH-30 is another example of bowl-shaped magnetic fields with the ejection jets in line with the axis of HH-30. The externally electrically driven plasma jet, as shown in the lower image, is very steady and it fades gradually, whereas the jet of HH-111 has dramatic pulse formations and a sudden cutoff at the tip. The structure we see in the jet of HH-111 does not fit with what would be found in an externally electrically driven plasma jet. So I must conclude that the jet of HH-111 is not externally electrically driven. This same logic would apply to the jet of M87. This jet is not a continuous structure that would be expected if this was truly externally electrically driven, as the jet on the right is. But we do see the common overall shape of the jets due to the shared magnetic bowl structure responsible for the jets in both M87 and the jets in the vacuum chamber. As we examine the Crab pulsar, we see that it is also easily explained with a bowl-shaped magnetic field. Here we can see the knot-like pulses that are emitted by the magnetic bowls in the vacuum chamber. Also notice how the plasma is choked down by the choke ring as it flows up into the upper bowl. You can find a lot more information out about pulsars on my Facebook page. This includes a very interesting study on pulsars that was released in January of 2013. This study brings further validation to the theories of pulsar behavior presented in the primer fields. Now we are going to look at supernova remnants. Supernova remnants are all that are left of a star after it explodes or goes supernova. Astrophysicists believe that all of these bubble-type supernova remnants once had a star in the middle of them. Then they believe that the bubble we see is a shell of gas moving away from where the exploding star once was. But I am now going to show you that this concept is incorrect. So we need another explanation for what formed these bubble-type supernova remnants. Occam's razor is accepted in science as a way to determine which solution to a problem is most likely the correct one. The goal when using Occam's razor is to provide the simplest solution possible. Therefore, in line with Occam's razor, I'm going to show you a very simple explanation of the forces behind bubble-type supernova remnants. The solution you are about to see would apply to all bubble-type supernova remnants, as well as many other bubbles that are observed in space. As you may have expected, the solution is found in bowl-shaped magnetic fields. So here again we see the confinement dome, the flip ring, and the choke ring. Particles of matter are drawn down into the magnetic bowl and down to the flip ring. The particles of matter flip magnetic orientation at the flip ring and then become trapped under the confinement dome. As the matter continues to accumulate under the confinement dome, it causes the confinement dome to swell in size. In other words, the bubble is continually growing. This is why when they measure these bubble-type supernova remnants, they are found to be expanding. Notice the lip at the bottom of Tycho's supernova remnant. This is where the flip ring is located. Then we have supernova remnant SN 1006. Notice the appearance of the top of this bubble. Notice the axial formation up through the middle of this supernova remnant. There are times when the internal pressure of the bubble is too great and the magnetic bubble will fail at its weakest point. The choke ring may also allow some matter to escape out of the bottom of the bowl. This is exactly what we find in the Jellyfish Nebula. Scientists have studied supernova remnants with a wide variety of instruments. When you carefully check all this data, you will find that it all conforms to the theories of supernova remnant formation presented in the Primer fields. One of the most thoroughly studied supernova remnants is SN 1006. This image of SN 1006 shows what is seen in wavelengths of light visible to the human eye. Now added to the Hubble image, we have that which is seen in other wavelengths by other telescopes. Where the magnetic field is the strongest is at the choke ring, and this is also where matter is compressed to the greatest density. This is why the choke ring area of SN 1006 is the only part of SN 1006 visible to the human eye. This is where matter has the highest density and becomes visible. Notice that other images of SN 1006 and other wavelengths also conform to the structure that would be expected within a bubble formed by a bowl-shaped magnetic field. Here we see the flow of matter going down to the flip ring, and the ejection of matter out of the top and out of the bottom of SN 1006. Notice that this matches the flows that we saw earlier in the Vela pulsar. Then we have this very interesting supernova remnant. I will just let the images do the talking. Then as we observe the Ring Nebula, we also see that it too is actually formed by a bowl-shaped magnetic field. So based on what we now know about how bubbles are truly formed in space, the massive bubble structures that have been discovered in our own Milky Way galaxy make complete sense. Then we have this new study that I just received this morning, which also confirms the theories presented in the primer fields. The magnetic nature of our universe is undeniable. The formation of Eta Carinae is no longer the mystery that it once was. The Eskimo Nebula is also easy to understand once you realize that it too is formed by bowl-shaped magnetic fields. Notice the bubbles inside of the nebula referred to as M29. So now that you know the patterns to look for, you will see that there are many confirmations of the primer fields theories found throughout the universe. In this image of CMS 147, we see the flip ring, the choke ring, and we can see the matter ejected out of the top of CMS 147 at less than escape velocity, and therefore the ejected matter is drawn back down to the flip ring of CMS 147. In this image of the Rosette and Cone Nebula, we can find three magnetic bowls with bubbles in the bottom of them. There is one bowl on the right, one faint bowl in the middle, and of course the large bowl with the bubble in the bottom that we see here. The bubble nebula is clearly in the bottom of a bowl. Then active galaxy NGC 4438 is shown here with the bubble that it contains. By By now you don't even need me to show you the bowl-shaped magnetic fields that form the infamous Hourglass Nebula. You can even see the confinement dome down inside the Hourglass Nebula. So let's review the basic structure inside these bowl-shaped magnetic fields. The red bowl represents north magnetic orientation, and the blue bowl represents south magnetic orientation. The shape of the magnetic substructures within the red and blue bowls is identical, except they are of opposite magnetic orientation. In stars, the two bowls would be at the poles of the star, and the flip point would be the focal point, or the nucleus, of the star. In the Primer Fields Part 5, we will look at how these fields function in the Sun, including why the Sun flips magnetic polarity every 11 years and the true reason behind the solar cycle. Notice that in the vacuum chamber experiments, you can see that there is a brighter inner magnetic bubble in the middle of the outer magnetic bubble. In other words, there is a bubble within a bubble. In NGC 3918, we also see a bubble within a bubble. Then the Cat's Eye Nebula also has a bubble inside of a bubble formation that cannot be explained by the currently accepted theories. But when we apply the Primer Fields approach, you will see that these bubble-in-bubble structures are very easy to explain. So as you can clearly see, all of these bubble-in-a-bubble type formations are very easy to understand once you actually know the real truth. There are also rings observed in space, and here you can see how these rings can be formed between two bowl-shaped magnetic fields. Then we see again how the Red Square Nebula could be formed between two bowl-shaped magnetic fields. Now we are going to take a look at how these bowl-shaped magnetic fields are responsible for what has been discovered in and around Saturn. Saturn's rings are so pronounced because the rotational axis and the magnetic axis of Saturn are exactly aligned with each other. Saturn is the only planet in our solar system with this exact alignment, and that is why rings are not as defined around other planets as they are on Saturn. The rings around Saturn are held in place by the bowl-shaped magnetic fields, just as the disk of plasma is in the vacuum chamber experiments. The spokes that appear in the rings of Saturn have long been a mystery. But when you apply what we learned in the vacuum chamber experiments, the cause of these spokes become very clear. Notice that these spokes are at a tangent to the surface of Saturn. Notice how the burst of plasma emissions from the center of the vacuum chamber are also at a tangent to the rapidly rotating core in the vacuum chamber. When we overlay the vacuum chamber video with the images of Saturn and its rings, the solution to the source of the spokes in Saturn's rings becomes obvious. Then we can see that the primer field theories also clearly show the true reason behind the polar auroras on Saturn. Shown here is the basic magnetic field structure that exists around Saturn. Then this image of Saturn's North Pole captured the interest of the whole world. But it's not really that difficult to explain once you understand the theories and concepts presented in the primer fields. If you look closely, you will even see the magnetic bubble in the middle of this image. Then, of course, we have the intriguing hexagonal pattern seen in the pole of Saturn. Around the axis of these bowl-shaped magnetic fields, we find that these fields will cause matter to form these regular polygonal shapes. In the ring of steel balls around the nucleus in this image, we also see this polygonal effect. So as you can see, most all of the mysteries of Saturn are very easy to explain when you apply the theories that you have learned in the primer fields. Now let's take a look at Jupiter. Here we see that Jupiter's magnetic axis and rotational axis are not quite aligned, and that is why the rings of Jupiter are not as pronounced as the rings around Saturn. Notice the appearance of the polar areas of Jupiter. This image from NASA reveals the ring formations around Jupiter. These views of the poles of Jupiter reveal very organized patterns about its axis. Next to the red asterisks, notice the dark spots on Jupiter as they rotate by. Now notice these same type of flows on the bowls in the vacuum chamber. You can see the fingers of plasma on the lower bowl in this image. Then with the larger bowls, we also see the same type of pattern next to the glowing sphere. So by applying the theories presented in the primer field series, we can see that we now have a very logical explanation for the patterns that we observe on the surface of Jupiter. That brings us to the end of the Primer Fields Part 2. In this installment, we learned about the magnetic substructures that are found within the bowl-shaped magnetic fields. You learned about how ejection jets truly function. You were shown clear proof of bowl-shaped magnetic fields at work in the Vela pulsar. The forces at work in bubble-type supernova remnants were also revealed. We also saw that bubble-in-bubble type nebula are easily explained using the theories presented in the primer fields. Then we ended with a brief discussion of the forces at work in and around Saturn and Jupiter. In the primer fields part 3, we will be exploring the wave-particle nature of matter. This will include an in-depth examination of light and the reason it exhibits the dual nature that we find in the infamous double-slit experiment. Although we know a lot about light, there are still some mysteries as to how it is truly structured and functions. In this installment of the Primer Fields, we will reveal the true structure of light and thereby unlock some mysteries that have perplexed the world's brightest minds for centuries. You will be shown what is truly behind the dual nature of light. It will be revealed why light has the properties of both a particle and a wave. In other words, it will be shown why light can be proven to consist of discrete units known as photons, and yet have wave properties at the same time. Then we will see this same structure would apply to all electromagnetic radiation as well as all matter. This explanation will also reconcile the infamous double-slit experiment in a way that most anyone can comprehend. Since the double-slit experiment is at the core of quantum mechanics, this has profound implications for the future of quantum computing as well as many other future technologies that will be built on this knowledge. Some of this future technology is already here, but that will not be revealed until Part 7 in the Primer Fields series. In this installment of the Primer Fields, we will discuss edge diffraction, single-slit diffraction, dual-slit diffraction, and many other aspects of light as well as all electromagnetic radiation. The interesting thing is that the explanation to all of this is actually quite simple, and as you may have guessed, it is built on the Primer Field structure. So let's start to unravel our little mystery. In this demonstration of the dual slit experiment, we see a red laser, a yellow laser, and a green laser being used to show how the different wavelengths or colors of light respond when they pass through identical double slits. This experiment clearly shows the wave nature of light, and yet we know from other experiments that light is made up of discrete units or quanta of light that we refer to as photons. Notice how the patterns of the three different colors vary. This is a very important clue. Then with single edge diffraction, we see the very intriguing patterns around the edge of the razor blade. This is another very important clue. We also have important clues revealed in the continuous spectrum of light that is shown in these single slit experiments. Experiments that have been undertaken with electrons also have left us with some important clues that will also help us solve this mystery. This chart shows the frequency, wavelength, and energy levels of electromagnetic radiation. This is yet another clue. This is a diagram of the electric field and the magnetic field of all electromagnetic radiation. One more clue for us to use. Here we have the structure of one unit, or quanta, of electromagnetic radiation. The red field is of north polarity and the blue field is of the opposite polarity. Then we see how this structure would fit into our diagram of electromagnetic radiation. So the size of the fields is determined by the wavelength of the electromagnetic radiation. Therefore, the field size is equal to one cycle of the wavelength, with the zero crossing point being centered on the nucleus of the fields, or photon in the case of light. Now we are going to take a look at the internal flow within this single photon. Again, this would apply to all electromagnetic radiation. The green sphere represents the photon. Here we have the internal energy flow within the fields of the photon, as well as several other views of the photon and its fields. The image in the upper right corner shows how this is related to our vacuum chamber experiments. The same flows are at work in the vacuum chamber. Now around the core of this photon we have the bowl-shaped magnetic field emitters that were first revealed in the primer fields part 2. Then as we zoom in on the core of our photon, we see the flip ring and the choke ring. Then notice that the incoming particle flow is not just particles. Each particle flowing within the photon's fields also has the same bowl-shaped magnetic field structure to it as well. So these flowing particles are not really particles at all. They are actually concentrations of energy. These flowing concentrations of energy also have the same internal flowing structure as the photon itself does. The photon is actually a concentration of energy made up of many flowing concentrations of energy, which are made up of many flowing concentrations of energy. How many levels down this repeated pattern goes is unknown. The green circle in this image represents the concentration of energy that we refer to as the photon. But as you can see, there is a lot more to the photon than just the energy concentrated in the middle of the photon's fields. The exact size of the photon in relation to the fields and where it is exactly in relation to the flip rings still needs to be determined. This image is only meant to give you an idea of the overall system and not meant to be an exact scale model. In reality, the photon is much smaller in relation to its fields than shown here, but this ratio is more effective for showing the inner workings of a single photon. After the incoming concentrations of energy hit the flip ring, they become trapped inside of the green circle, or photon. But as you can see, some of this trapped energy escapes at the equator of the photon and is recycled back into the flip ring yet again. This is the same pattern that we see in the vacuum chamber experiments. Now let's take our single photon and its fields and put them in a single row with other photons. Remember, the actual fields that are shown here in red and blue are actually invisible. The green spheres are the photons themselves. The red fields represent north magnetic polarity and the blue represents south magnetic polarity, and therefore they are naturally attracted to each other, and the spacing between the photons is maintained by this field structure. Now the photons will go by us just missing us, but the fields of the photons do hit us. In the real world, this of course would make the photons turn slightly because of the drag on the fields on the side of the fields hitting us. Photons can be turned by an obstruction in the path of the photon's fields, even if the obstruction does not contact the photon itself. This is how light can bend around an object. Also remember that each photon's field structure has the flow shown in the lower left corner. Again we see the diagram of electromagnetic radiation, and you can clearly see how this diagram agrees with the structure of our photons and fields. So the ball of confined plasma in the vacuum chamber has the same basic structure as a photon. Now let's take our white photon and split it up to give us 6 different wavelengths, or colors, of photons. The photons are now shown with the relative sizes and spin rates. This animation is just an approximation to give you the basic concept, and not meant to be an accurate scale model. The important thing to note is that the smaller the photon, the higher the spin rate. This would apply to all electromagnetic radiation. The violet photon has a shorter wavelength than the red photon, and it also has a higher spin rate. The violet photon also has a greater energy level than the red photon. Therefore, the shorter the wavelength, the higher the spin rate, the greater the energy level, and the smaller the photon. This would logically apply to all electromagnetic radiation. Then, of course, the wavelength is related to the field size, and the field size is related to the photon size. Let's do a quick review of the internal flowing energy structure of a single photon before we move forward. The flowing structure is the same for all electromagnetic radiation. Once more, we see that wavelength is related to field size. Here we have rows of photon fields with a corresponding waveform. So you can now see that the waveform clearly represents the size of the fields around a photon of electromagnetic radiation. Now the fields are shown as red and blue polarity fields. This image represents what happens to the fields as a row of photons pass through the glass. Notice how the fields are compressed as they pass through the glass. Remember that the fields are actually invisible. Now we have a row of photons that we are going to observe as they go through the glass. Let's attach a light speed indicator to one of the photons to keep track of its speed. Watch as the photon decelerates as it enters the glass. Then the photon accelerates back to full light speed as it exits the glass, and the other photons in the row also accelerate back to full light speed upon exiting the glass and re-establish their normal spacing. Now we are going to have a race between two rows of photons. Only one row of photons is going to pass through the glass. Notice how the fields of the bottom row of photons are compressed as they encounter the glass. Then as they exit the glass, the compressed fields rebound and push the photons away from the glass, thereby re-accelerating the photons back to full light speed. Let's have another race between rows of photons. Once more, we see how the compressed fields rebound as they exit the glass, thereby re-accelerating the photons to full light speed. This compressed field rebound is what is responsible for the movement of the optical fiber in the video to the upper left. So as the photons and their fields pass through the optical fiber, they compress like a spring. Then as this spring of photons and fields exit the optical fiber, they rebound and push off of the optical fiber, causing it to whip very slightly. So as you can see, light actually pushes off of glass as it exits the glass. Even the photons of light that are hitting your retinas from this video are being pushed off of the screen as they leave the screen because of the rebounding effect of the compressed photon fields. Then again, the size of the fields of a photon are determined by the wavelength of a photon. Here we see the typical waveforms that are used to represent visible light and other forms of electromagnetic radiation. But in reality, no such waveform exists. The waveforms are useful for discussing electromagnetic radiation, but light and other electromagnetic radiation does not move in a waveform pattern. In other words, light does not go up and down, or wiggle. Once more, we see that one wavelength is equal to the size of the fields. In this image, the upper row of photons are shown enlarged so that you can see the spin rate and relative size more clearly. I have also intentionally shown the upper photons as not having a hard spherical shape to emphasize that photons are actually concentrations of energy, just as the ball of plasma in the vacuum chamber is. Now we are going to see why light of different wavelengths have different angles of refraction. In other words, why we get a spectrum of colors when we shine white light through a glass prism. In this animation, time is frozen temporarily, and this has stopped the photons moving so that we can get a better look at the dynamics of this glass-photon interaction. As the row of photon fields enter the glass prism, we see that the different colors refract or bend at different angles. Then we see that as they exit the glass prism, the photon fields also refract at different angles according to the wavelength or color of light. Clearly the light refracts at the surface of the glass prism, and the photon fields highlighted in white are what we want to focus on. Now we are going to watch as two photons and their fields travel through the glass prism. We can clearly see that the violet photon fields refract more as they cross the glass prism surface than do the red photon fields. Then as the photon fields exit the glass, we also see that the violet photon fields refract more sharply than the red photon fields. This time we are going to zoom in to watch as the photon fields enter the glass prism. You can clearly see that the violet photon refracts more sharply than the red photon due to the size of the fields. So the smaller the fields, the more sharply they will refract. Since field size is related to the wavelength of the light, this agrees with what we actually find when light is refracted by a glass prism in the real world. Let's watch as the red photon fields enter the glass prism. Notice how the leading edge of the photon's fields hit the glass first, and this turns the photons as it enters the glass. Then as the photon enters the glass, the fields are compressed, just as we saw in the photon races we ran just a bit earlier. Now as the compressed fields exit the glass, they rebound. Since one edge of the photon fields exit the glass first, it rebounds first, thereby pushing that edge of the photon and turning the photon and its fields. Again we see the red and violet photon fields as they pass through the glass prism. So now you know why light refracts as it passes through glass or other transparent materials. It is very simple once you know how photons of light are actually structured. Again, we see that the fields around a photon are of opposite polarity. Here we have some rows of photons aligned with their corresponding waveforms. Now we are going to overlap the rows of photons. When waveforms align with each other, they are referred to as being in phase. When the waveforms are not in alignment, they are referred to as being out of phase. When the photons' fields overlap in phase, the red polarity fields line up with each other, and the blue polarity fields line up with each other. This results in an increase in energy, and the photons shine more brightly. This is referred to as constructive interference. When the photon fields overlap out of phase, the fields of opposite polarity line up with each other, and the energy flow of the red field cancels out the energy flow of the blue field. This results in no energy going to the overlapping photons, and they therefore emit no light. In other words, both photons go out when they line up out of phase. This is referred to as destructive interference. As the photon fields continue to move, we see the constructive and destructive interference. This is why the light either goes out or gets brighter in laser interference experiments. You can see that this is not a simple on-off situation. The more the overlapping fields line up in phase, the brighter the photon will shine. Then the closer the fields line up out of phase, the more the photon dims. This is why there are not sharp cutoffs in the interference patterns. There is a gradual transition from light to dark in the interference patterns because of this effect. Now we have two flat panels of photon fields. Notice that the panel of photon fields on the right can rotate. In reality, the overlapping fields would result in no light at all, but the limitations of the animation software I used would not allow me to achieve the effect I desired here, but you get the idea. Now watch what happens as we rotate the one panel of photon fields. Now let's get to edge diffraction. Notice the intriguing patterns around the edge of the razor blade. This animation shows a photon gun that will emit a single row of photons across the yellow edge. Notice that the more the photon fields hit the edge, the more the photon and its fields are refracted. The photon itself still goes by the yellow edge, but its path is altered because of the drag of its field going across the edge. So if we have photon fields crossing the yellow edge at various levels, we will get a range of diffraction, as shown here. Then as these diffracted photons cross each other, we see our interference patterns emerge. This is the reason we see these interference patterns around the edge of the razor blade. Now we are going to discuss slit diffraction, which is basically just edge diffraction, but with two edges that are parallel to each other on opposite side of a beam of photons. As you can see here, the widest slit results in the narrowest pattern. A greater percentage of the photons passing through the narrow slit are affected by the edges of the slit than is the case for the widest slit. So the edges of the wider slit affect a smaller percentage of the photons passing through the slit than would be the case for the narrower slit. In this demonstration provided by MIT, we see a red laser shining on a single slit, which will vary in width during this demonstration. So as the slit width increases, the pattern becomes narrower. Then as the slit width decreases, the pattern gets wider and more diffuse. Here we see our photon gun again. But this time our photon gun has been modified to emit two rows of photons with their fields at the same time. A single slit gives us a fan-shaped pattern of photons and their fields. Now let's see what would happen if we had two slits with photons passing through them. The distance between the slits is varied so that we can observe changes in the interference pattern. These interference patterns are the result of constructive and destructive interference. Now you know the true cause of the perceived dual nature of light. The fields around the photon obviously result in the wave-like behavior of light and other electromagnetic radiation. But we still have an issue with the double slit experiment that we need to address. The interference pattern still shows up even if we fire single photons or single electrons through the dual slits. The photon or electron seems to interfere with itself, but how can that be? Up until this point, I have been showing you a simplified version of how the fields are truly structured in order to avoid confusion. There is a lot more to these fields than just what you have seen thus far. Now it's going to get a little more complicated as we start to discuss how these magnetic fields overlap each other and interact with each other. Here we have the photon and its fields again. But in reality, the electromagnetic fields do not just stop at the limits of the fields shown here. They continue out much further, but they also get much weaker as they go further away from the photon. Now we see the red field extending out much further than what we have discussed up until this point. Again, this extended electromagnetic field is much weaker on the outer limits than it is next to the photon. Now we see the extended blue electromagnetic field. The further you go from the photon, the weaker the fields. Notice the interesting similarity to the wave function of hydrogen 421. Now we have two photons. Now we have the extended electromagnetic field of these two photons. Notice how the extended electromagnetic fields overlap each other. Here we see the extended fields represented in wireframe. Now we see the extended fields overlapping each other. Let's add some photons and fields so that we have a row of photons and fields. Here we have one set of extended electromagnetic fields, and then two sets of extended electromagnetic fields. Now we have all of the photons' extended electromagnetic fields. You can see why I have avoided discussing these extended electromagnetic fields until now. But the way in which these fields overlap is very important when it comes to understanding the double slit experiment and how the bonds in matter can be so strong. So you can see that the extended electromagnetic fields extend well away from the photon, just as the fields of our Sun extend well out away from the Sun. The fields of the Sun extend out past Pluto, and even that far from the Sun, the solar wind still carries charged particles. So you could think of the Sun as a giant photon. Again, we have a single photon with its extended electromagnetic fields. One of the most intriguing experiments in physics is the double slit experiment. Until now, there has been no satisfactory explanation for the interference patterns that result when you fire only one photon or one electron at a time through the slit. It is as if the photon or electron interferes with itself. But this apparent paradox is resolved when you understand that photons and electrons are not just balls of condensed energy. Photons and electrons are also surrounded by their electromagnetic fields that are much larger, and there is energy flowing in these extended electromagnetic fields. The photon or electron passes through one slit. Then some of the energy of the extended electromagnetic field passes through the other slit, and this energy interferes with the photon or electron energy that went through the opposite slit. This is why a photon or electron can interfere with itself. The mystery of the infamous double slit experiment is no longer a mystery. That brings us to the end of the Primer Fields Part 3. I am currently planning a total of 7 installments to properly cover the basics of the primer fields and the implications they have on our world. So we have 3 down and 4 to go. In this installment of the primer fields, we learned about photons of electromagnetic radiation and the electromagnetic fields that surround them. We saw the true cause of constructive and destructive interference. It was shown that when the electromagnetic fields of the same polarity line up, we have constructive interference and the photon glows more brightly. Then we saw that when electromagnetic fields of the opposite polarity line up, they cancel each other out and thereby dim the photon. This we learned is the true reason behind destructive interference. We saw how a sharp edge could cause photons of light to diffract around the edge and give us the intriguing interference patterns we see here. We examined slit diffraction, 1 photon at a time. The reason that light slows down in glass and then accelerates back to full speed on exiting the glass was shown. Then we saw that we could now explain this optical fiber whip due to the fields of the photons pushing off of the end of the optical fiber as the photons exit the fiber. The true reason that light refracts as it enters and exits glass was revealed. We saw that the angle of refraction for photons is determined by their field size. So the next time you see a rainbow, you will know the science behind its beauty. Then we ended by solving the long-standing mystery of the infamous double-slit experiment. In the Primer Fields Part 4, we will be discussing the structure of matter down to the subatomic level. Now it's going to get really interesting.